So one thing you'll know about me is that I like using whiteboards because I don't know, it's fun, it's cool. Um, yeah, I think that's enough reasons. Um, um, and I feel like I'm able to articulate things a little bit more. So one of the chapters that people tend to like me explain is the chapters that starts off with the Brownian motion stuff. So I tend to call it the Brown stuff. Um, and what some students tend to get annoyed with is that I tend to start off with a little bit of a step back before I even touch on Brownian motion, where I actually talk about um, studies thus far. Let's see for a different color. And I usually start off with a little discussion about what we've sort of been learning so far. So in essentially in Brownian mode, you learn Brownian motion in subject A, who in subject A214, which is essentially supposed to be the last exam that you do before you start with your 300 series. So before then, you should have done your 213 and your 212 and your 211, right? And essentially in 211, you learning present value, and then in 212 you learning probability. I'm oversimplifying things here. 213 you essentially learn expected present value. So then coming to 214, what are you learning? And if you think about the subject, the structure of the subject, you start off with, let's call it fluffy stuff. And then you do some, let's say easy or somewhat easy investment models. And then you go on to the whole stochastic stuff, and then you move on to that 5-step stuff, and then you randomly end off with like your rune theory and your run of triangles. But and I forgot the most important thing actually. And then randomly in between your fluffy stuff, you got this measures of risk chapter, right? In terms of the fluffy stuff over here, we're talking about thinking, how investors think, or behavior of investors, and all of that stuff, some of the assumptions they make. It's really about the assumptions and the theory of the assumptions that they make. And then you've got this measures of risk chapter. I'm going to skip over that one. And then we do an investment model. Then we do stochastic models. Then we do that 5-step method stuff. This has to do with manipulating models, but essentially still models. Same thing here with rune theory and triangles. It's also a model. If you think of the fluffy stuff here at the beginning, this is a model of thinking. It's a decision model process. If we take a step back, if we look at 213, you're learning about time series which is a model. What is all in there? Your mortality stuff you learn in the what am I saying? EVT, extreme value theory. There we go. EVT. You do that there as well. There's also models. It's a whole lot of models. Even this concept of a present value. Intuitively, it makes sense, but it is also just a way of thinking. And all these things over here, what they're doing is they're attempting to explain the real world, right? So if we think of purpose, all of these models only really matter if they can do this. So does it make sense that I use rune theory to try and price a life product, for example? Makes no sense. But does that mean the models are wrong? No, it just says that the model is inappropriate for that purpose. So models are there essentially in an attempt to explain what happens in the real world. So a model only really gains its value based on its usefulness. So all these different things that you learn, it's more important that you know how is it useful, why is the model useful, than anything else, really. Because in the end of the day, you use these models for decision making, and that is essentially where the crux of the matter comes down to. And in order to make a decision, there's an element of communication that must happen, and the output of models, all these models and stuff that we tend to do, we tend to use all these models to measure some sort of risk. And at a very basic level, you would looking for your expected value, and you would look for your standard deviation or your variance. You'd be looking for, I should use capital, your variance to sort of help you make those decisions. So when you think about models in general, that must be what must be running around in the back of your mind, that you're wanting to explain the real world, so that you can make decisions, or you can make useful decisions in the end. So when we do talk about Brownian motion and stochastic calculus, I'm always going to pull you back to these concepts, because the quicker you make that connection, the quicker you will understand the purpose behind this topic, and also it might solidify your understanding of time series that you did in 213, because the two are quite nicely linked together. So this is essentially an introductory video where I'm speaking about that context. So brown stuff. I'm not going to do any maths now. I'm just going to talk about the brown stuff. So you would have noticed that there's a little story that is explained in your notes. Story. about the botanist. The botan. And hopefully you would have asked yourself the question, why is there a botanist involved with this? And uh, for those that are watching this, correct me if I'm wrong in the comments, but he actually didn't do any of the maths. But it was actually, I'm not going to spell his name, Mr. Einstein. That was, okay, I think he was, no, that's Isaac Newton. Anyway, it was Einstein's theory, but it wasn't that popular back then. But then the botanist, Robert Brown, went out and he published also correct me if I'm wrong, a poem. And if you Google it, you'll find that poem. And it's a bit, that poem's a little naughty, but what that poem is doing, it is talking about the real world. So it speaks about how there's this river and how there are particles, which are the what was it? The pollen that was moving in the water and bouncing around in a random fashion, yet they seem to have followed some sort of route. And magic happened somehow, and people were to put together that, oh, this is this random movement thing that Einstein was talking about, and it's literally just this thing of, oh, there's a model that exists that can explain this real world situation or this real world phenomena. And that is the important part of the story, as to why it's even part of your core reading, is this whole thing of a mod. Here's an example of an arbitrary model that is good at explaining something that's happening. If you jump to, I'm not sure how much of it is covered in 8212, but if you jump to your copula, for example, and we speak about the Archimedean copula, if you really think about the maths behind it, this is now assuming you know what I'm talking about, the principles are actually quite arbitrary. You get taught the maths first and then shown how it appears in the real world. Whereas this is a case where the real world was observed and then a model was attached to it, which is generally how you would be doing models. Whereas when we think about copula, the order of logic goes the other way around, which makes it a little bit more difficult to understand. But the point is, it's that the story is about taking a model and fitting it to the real world, and that is where that condition of usefulness was being met. Remember earlier on I said the only reason we do these things is if it is useful. And then the question that we then ask is then, how is this thing useful? And it would only be useful if it aids in it aids in decision making. So how does this whole process of determining this thing aid making a decision? Um, so we already know this thing is going to eventually talk about option pricing and derivatives and what else is there? Just your normal simulations. I'm going to put risk management down here. Okay, then under risk management, your capital management would also sit there, determining all of that. But essentially, all of these things tend to revolve around this whole principle of measures of risk, because that is what is needed in order to do all these things. And that's where these decisions come from. So measures of risk is what you're looking for when you are learning about Brownian motion. So when you're studying the content, it's important to remember what your objective is. So in the back of your mind, don't think about it constantly and as you're learning your content, but remember in the end what you're looking for is some sort of expected value, some sort of measure of risk, and possibly a quantum of value at risk or a tail value at risk. So keep that in mind as you're studying, because you will get blinded by all of the maths and all of the stats. But if you know where your content is going, then it will be a lot easier to grasp a lot of the concepts when you go through the work. So this is my little introduction to that chapter, and then hopefully if you like this introductory video, and if I feel inspired, I guess, then we'll move on to starting off with what a stochastic process is first before jumping into Brownian motion. That's also one of the mistakes that students would still do, is that they skip that very first paragraph, and then they forget what a stochastic process is in the first place. But anyway, we leave that when we chat again. But drop your comments, let me know what you think. My PC died, so this is being shot from my cell phone, so not the greatest of quality, but if it works, it works. And I've got lots of whiteboard, so yeah. Thanks.